In this video, we are going to take a brief overview look at the computational thinking and the networks and systems design standards. You will probably want to go back and take a deeper dive into these, take some time to really read them through, maybe pull them apart a little bit, look at the nouns and the verbs and how it can be implemented in your classroom, how it relates to what you're already teaching. But in general, let's just take a peek at what the standards are asking. So I'm in computational thinking. I'm in that PDF that you find on that basic web page from the standards and instruction, computer science and digital fluency page. I've scrolled down to page 24 of that PDF to take a look at the standards. I see computational thinking along the top, modeling and simulation along the side, and then the standards are broken down by grade band and so on. So if I was looking at K1, here's that first standard for K1. If I was looking at 912, here's that first standard for 912. In general, what we're looking for in modeling and simulation is creating or exploring models that talk about predictions and outcomes. So this is done quite often in science class and in math class. It can be done during research in an ELA class or in a science class for sure. But the idea here is that they're thinking about how they can create a process or explore a computational model that shows input and output. The next one down, data simulation and visualization. Here we're thinking about how you can organize your data, how you can collect it. So it might be doing surveys, it could be exploring digital tools that collect data, whether it be something in science class on velocity or temperature and so on that you might use in math or science class. Going down to the third one, here we're thinking about how we can visualize data. We do this a lot in science and in math. We might do this in a research project in our ELA class or in social studies. It might be something that we're exploring with our students in order to visualize what data can look like. The first one in abstraction and decomposition, we're looking at problem solving. We're really looking at how you can break down a problem into multiple spots, or you might be able to solve a problem in multiple ways. This is definitely something done in math class. It can certainly be done in English, thinking about how you can do steps to, in a how-to essay. It could be writing a simple program, whether you're using coding language or whatnot, to be able to explore what the standard is asking you to do. The next one, number 5, we're talking about that sometimes tasks can be repetitive, or they can be done, or they can be explained in different ways. You can think about how you solve a problem. So this could be done in an SEL class. This could be done when you're talking about how-to essays. It could be looking at science data or thinking about a function in math. The next one down in algorithms, this is really just a step-by-step process. So we do this every day in class. We might have students line up in different ways, or we might take a look at the step-by-step on how to solve a math problem or science problem, or looking at items that led to the Civil War or World War II. So you're really thinking about the steps that led to something, or the step-by-step process to organize ideas. It could be a recipe, for example. Going into number 7, our CT7, we're in algorithms and programming still. Here we're talking about identifying the values. So here we're thinking about what stays the same. So today's date, even though the variable changed, it's still a date on a calendar. It could be identifying the processes that you need to run a program, or how you can remix information that you're doing in order to see how data changes. So maybe it's changing something in a science experiment or changing a variable in a math problem that's going to help you along those lines there. For algorithms and programming, we're thinking of the tasks that consist for repetitions. We're talking about loops here and conditionals, thinking about how we can remix different things. Think like Mad Libs, for example, where you can remix certain elements of it, the nouns and verbs and so on, but the content or the context doesn't change. They're still going to the zoo, for example, in that Mad Libs activity. Moving on to 9, we're thinking about debugging. When you're editing an essay, you're debugging it for the reader, right? So you can talk about debugging in the writing process. If you're looking at a math problem and you're trying to figure out what you did wrong, you're debugging that math problem. If your science experiment fails, you're thinking about that as well. So, think about ways that you can think about getting rid of any errors that might be in your data. Moving on to networks and systems design, first for hardware and software, we're thinking about input and output and how that works for different computing programs. It's being able to identify the basic hardware. So can your student identify the difference between a trackpad and a mouse? Do they understand what input is for typing into a computer versus output where something might get printed, or it might show something on the screen? For networks and systems design, as we're moving on to the third one, again, we're talking about the basics, hardware and software, but what happens when something doesn't work? So this could be troubleshooting something that's not working in your classroom, or fixing your Chromebook that might not be working correctly. And then as we move on to 4, we're moving to networks and the internet. We're thinking about how you do something. This could be a guidebook for how you can talk about different things with the internet. It could be designing a protocol and how data is going to move through processes and so on. And then for the last one in networks and systems design, for networks and the internet, we're thinking about those physical devices, so a hard drive or some sort of thumb drive that's going to store information. And then as we get up into the upper grades, thinking about emerging technologies. So here you can talk about artificial intelligence, mixed reality, augmented reality, user experiences, and different careers that are involved now in technology and how they're being used and how it affects the systems that we have.